Remember those days of visiting the summer lake house, the swimming and boating expeditions, the summer sun, and your cruel cousins? Nah, me either. Welcome, detectives. My name is Jason Richards, Microsoft technical trainer and data detective, and we won't be talking about summer lake houses, but rather Fabric Lakehouses. We'll unlock mysteries like what they are, how to work with them, and even more important, how to secure them. First things first, what's a lake house? Our first mystery we'll call the lake house case. Pretty simple. A lake house presents as a database and is built on top of a data lake using Delta format tables. Lake houses combine the SQL-based analytical capabilities of a relational data warehouse and the flexibility and scalability of a data lake. Lake houses store data in all formats and can be used with various analytical tools and programming languages. As cloud-based solutions, lake houses can scale automatically and provide high availability and disaster recovery. Let's look at some of the benefits. From the data lake perspective, lake houses offer scalable, distributed file storage and the ability to use flexible on-read schemas as opposed to predefined schemas. From a data warehouse perspective, lake houses support ACID transactions, which we'll talk about in a little bit, through Delta tables and a SQL endpoint for native SQL querying, as well as the flexibility of using Spark. A lakehouse is a great option if you want a scalable analytics solution that maintains data consistency. It's important to evaluate your specific requirements to determine which solution is the best fit. Now that you understand the core capabilities of a Microsoft Fabric Lakehouse, let's investigate the clues on how to work with Fabric Lakehouses. Before you can create a lakehouse, you create a workspace in the Fabric platform and configure your workspace to allow Fabric resources. You create and configure a new lakehouse in the data engineering workload. Each lakehouse produces 3 named items in a Fabric-enabled workspace. The lakehouse item contains storage and metadata where you interact with files, folders, and table data. This interaction happens through the Lakehouse Explorer interface. The SQL Analytics endpoint is a read-only SQL endpoint through which you can connect and query data with Transact SQL or T-SQL. The semantic model is an automatically created default data model based on the tables in the lakehouse. Power BI reports can be built from these semantic models. The Lakehouse Explorer enables you to add and interact with tables, files, and folders in the lakehouse. When a lakehouse is created, a tables and files folders are created. We'll cover that case in a bit. This is where you can also work with the data using Apache Spark and other data engineering tools. Another way to work with data is with the SQL Analytics endpoint. The SQL Analytics endpoint is a pseudo warehouse that is automatically generated from a lakehouse in Microsoft Fabric. A customer can transition from the Lakehouse Explorer to the SQL Analytics endpoint with a quick selection. The SQL Analytics endpoint is read-only, which is different than the warehouse item, which is read-write endpoint. So data can be modified through the lake view of the lakehouse using Spark. Via the SQL Analytics endpoint of the lakehouse, the user has a subset of SQL commands that can define and query data objects, but not manipulate the data. This allows actions like performing queries, creating views, inline table functions, and procedures to encapsulate your semantics and business logic in T-SQL, as well as manage permissions on the objects. The SQL Analytics endpoint can also be leveraged through some familiar SQL tools like SQL Server Management Studio, Azure Data Studio, the Microsoft Fabric SQL Query Editor. Okay, Lakehouse Explorer and SQL Analytics endpoint allows me to work with the data in the lakehouse. What about this semantic model you mentioned? What's that all about? Let's unlock the mystery of the semantic model mayhem. Every time a SQL Analytics endpoint is created, Fabric creates a default semantic model for analysts and business users to connect to for reporting. A semantic model has metrics that are used to create reports, and semantic models are automatically kept in sync with the data lakehouse, so you don't have to worry about maintaining them. You can also create custom semantic models to meet your specific needs. In Power BI, a semantic model is always required before any reports can be built. So the default semantic model enables quick reporting capabilities on top of the warehouse. Let's look a little bit more into this default semantic model. A default semantic model inherits business logic from the parent lakehouse, which initiates the downstream analytics experience for business intelligence and analysis. New tables in the lakehouse are automatically added to the default semantic model. Users can also manually select tables or views from the lakehouse that they want included in the model for more flexibility. Objects that are in the default semantic model are created as a layout in the model view. For report readability purposes, it's always a good idea in the semantic model to rename columns to more user-friendly names, as well as hide objects that users won't need to view. Semantic models, case closed. Now, let's uncover the clues of data. OneLake will obviously serve as our central data repository, but what about if I have data in cloud storage already and don't want to copy it into OneLake? Can we solve the case of not my data? Of course! Shortcuts are objects in OneLake that point to other storage locations. The location can be internal or external to OneLake. Shortcuts appear as folders in OneLake, and any experience or service that has access to OneLake can use them. Shortcuts behave like symbolic links. They're an independent object from the target. If you delete the shortcut, the target itself remains ineffective. If you move, rename, or delete a target path, the shortcut can break. You can create shortcuts in Lakehouses and Kusto Query Language or KQL databases. Furthermore, the shortcuts you create within these items can point to other OneLake locations: Azure Data Lake Storage, Amazon S3 Storage, Dataverse, and even Google Cloud Storage, which is in preview at this time. When creating shortcuts in a lakehouse, you have to understand the folder structure of the item. Lakehouses are composed of two top-level folders: the Tables folder and the Files folder. The Tables folder represents the managed portion of the lakehouse, while the Files folder is the unmanaged portion of the lakehouse. In the Tables folder, you can only create shortcuts at the top level. Shortcuts aren't supported in other subdirectories of the Tables folder. If the target of the shortcut contains data in the Delta Parquet format, the Lakehouse automatically synchronizes the metadata and recognizes the folder as a table. Now in the Files folder, there are no restrictions on where you can create shortcuts. You can create them at any level of the folder hierarchy. Table discovery doesn't happen in the Files folder. A lot's been covered, detectives. Oh, actually, I want to take that part out.
Which part?
That paragraph. A lot's been covered.
Okay.
So
and the 3-second hold?
Yeah,
Okay.
this is what I didn't know we were doing chapters in this, so I put like inherent breaks in there, but I forgot to delete that one.
All right, cool. Do you want to start at chapter 3 or?
Yeah, we can. Yeah, that's exactly where we can start.
All right, we'll continue in 3, 2.
Now, hopefully, you have a better understanding of Lakehouses in Fabric, but more questions come up. How do we ingest data into the Lakehouse? How do we explore and transform the data once it's in the Lakehouse? And finally, how can we analyze and visualize the data using Power BI and the default semantic model that the Lakehouse provides? Let's crack the case of worrisome workloads. First, let's look at the clues on ways to load data into a Fabric Lakehouse. You can upload local files or folders to the Lakehouse. You can then explore and process the file data and load the results into tables. Another option is to import and transform data from a range of sources using Power Query Online via Dataflow Generation 2 and load it directly into a table in the Lakehouse. You can use notebooks in Fabric to ingest and transform data and load it into tables or files in the Lakehouse. Also, you can utilize pipelines to copy data and orchestrate data processing activities, loading the results into tables or files into the Lakehouse. After loading data, you can use various tools and techniques to explore and transform it. Let's uncover the clues. Each Fabric Lakehouse can use Spark pools through notebooks or Spark job definitions to process data in files and tables in the Lakehouse using Scala, PySpark, or Spark SQL. Scala, call it whatever you want. Notebooks are interactive coding interfaces in which you can use code to read, transform, and write data directly to the Lakehouse as tables and/or files. Spark job definitions are on-demand or scheduled scripts that use the Spark engine to process data in the Lakehouse. We also have our trusty SQL Analytics endpoint, through which you can run transact SQL statements to query, filter, aggregate, and otherwise explore data in Lakehouse tables. In addition to using a data flow to ingest data into the Lakehouse, you can create a data flow to perform subsequent transformations through Power Query, and optionally land transform data back into the Lakehouse. Finally, data pipelines orchestrate complex data transformation logic that operates on data in the Lakehouse through a sequence of activities. Now remember that semantic model? You can use a default or a custom semantic model as the source for a Power BI report that enables you to visualize and analyze the data. By combining the data visualization capabilities of Power BI with the centralized storage and tabular schema of a data lakehouse, you can implement an end-to-end analytics solution on a single platform. Mystery solved. Okay, time to change hats from investigation to security. First up, the data in OneLake. Keep in mind that your OneLake is an object storage resource, fully integrated with Fabric, and OneLake uses a layered security model built around the organizational structure of experiences within Microsoft Fabric. You essentially use Entra ID along with options within Fabric workspaces and items themselves to apply security. Let's look at this from each level in the Lakehouse. Fabric Lakehouse permissions are granted either at the workspace level, item level, and within the Lakehouse itself. In the workspace settings, you can choose between 4 different roles. These permissions should be reserved for collaboration for all items within the workspace, not only the Lakehouse. The Lakehouse is a single item within the workspace, so access can be controlled at this level as well. You can grant access directly to the Lakehouse within Fabric, or you can grant access to be only used with the SQL Analytics endpoint. This access means users can connect to the SQL Analytics endpoint with other tools like SQL Server Management Studio to query the data. You can share items via a link, and as you create this link, you select the permissions for the audience, like the ones shown here. The People in Your Organization link allows people in your organization to access this item. It doesn't work for external users or guest users. The People with Existing Access link generates a URL to the item, but it doesn't grant any access to the item because they already have access. The Specific People link allows specific people or groups to access the report. If you select this option, enter the names or email addresses of the people that you want to share it with. This link type also lets you share to guest users in your organization's Microsoft Entra ID. You can't share to external users who aren't guests in your organization. Once you've created a shareable link, you can manage permissions and provide more advanced access options. Depending on the item being shared, you may find different set of permissions that you can grant to recipients when you share it. You can also grant object-level security by using the SQL Analytics endpoint and T-SQL to further control what users can access. You have the ability to use built-in roles or custom roles, and those typically involve grant and revoke permissions. And always remember to use the principle of least privilege when considering access. Leverage permissions accordingly, and keep in mind that you can apply these permissions to intra-ID groups as well as individuals. Enough talk. Let's apply knowledge to practice and revisit the trusty Detecto Lab 5000. Let's Lakehouse. Okay, back in our environment. So what we're going to do now is we're going to create a lake house. We're going to do a few things in here. The goal of this is to create a lake house. We're going to show you the security settings that we can apply at workspace level and then individual item levels. And then we're going to take it a step deeper and we're going to create a shortcut into an external data lake account to show you how shortcuts work and how easy it is to apply a shortcut into the Fabric environment. So the first thing that we're going to do is create a lake house. We're going to build all this from scratch, right? Eventually we're going to load data in here, create semantic models, and do reporting and analytics through this lake house. But for now, we're just going to create the lake house and show you some of the security settings in here. So I am in my Fabric content enabled, domain enabled workspace, which is named Data Detective. And we're going to go ahead and create a new lake house. And I'm going to get real fancy with this name here. I'm going to call it Sample LH, and we'll create this. Oops. So we'll do that. Sample LH1 and create. This is what happens when we test this stuff out. I got to practice before I get in here, right? Can't just do that. So now I have this, and that's it. I mean, all I did was just name it, and it created this for me. You can see that it's deploying a SQL Analytics endpoint as we speak, so I don't have to configure any of this. It's already created my lake house. My lake house is attached to the one lake. And then you can see it already adds a tables folder and a files folder. And this is where we'll apply our shortcuts later on. Now, to navigate through this, let's go ahead and navigate through this. You can see that the SQL Analytics endpoint is created. What can we do with this lake house once we have it? Well, I can refresh the screen. Also, by the way, you can see that all these different items show up. When we're in our workspace, different items that we brought up in a different browser window, I can bring these up and navigate back and forth through them. One of these is the endpoint, and one of these is the lake house itself. Right. So in the lake house, I can refresh the screen. I can change settings, the lake house settings. I can get data through uploads or different ingestion options that we'll go through in later exercises. I can create a new semantic model, should be a default one. And then because we're in the lake house version of this, I can open up notebooks and use Spark or Spark SQL or the different languages within notebooks in order to transform data or load data in here and work with it in that way. Then I have my SQL endpoint. So if I don't want to deal with Python or Spark or Scala or some of those other languages that I might not even be familiar with, all I know is SQL, there is a SQL Analytics endpoint. So there's a different screen for this. You can see that it gives you that nice, comfy, cozy feeling of being in a SQL environment where we have our schemas, our security options. I can create new queries. I can create visual queries, which are essentially no-code ways of viewing data utilizing a SQL endpoint. So not only can I programmatically use SQL, but I can create a visual query. And a visual query allows me to build, drag and drop tables there and do what I need to do in order to filter and join and aggregate certain items. So a no-code option as opposed to just writing SQL. All right. So Lakehouse, we have our analytics endpoint. Let's go back into the actual Lakehouse itself so I don't get that error again. And we'll talk a little bit about security. In order to do that, we're going to go back into our workspace. Now, if I go into here and I look at my manage access, you can see that I have 2 users. Now, these users are part of my Microsoft 365 account that I've added in here. So we got Vidi Vigilante and we got Gary Gumshoe. I got Gary applied to a viewer role, and I have Vidi at a contributor level role. So what we're going to do is we're going to see how these built-in roles apply to the Lakehouse items in our environment. I can add people, I can change their access. So this, as an admin, I have these types of abilities to manage access into my workspace itself. And a workspace administrator can do this as well. So even if I add other workspace admins, they could do the same thing. But what I want to see is how this affects my permissions within this item itself. So at the Lakehouse level, let's look at that. If I go into the More Options tab, I can view Manage Permissions. And then we can see from a Lakehouse perspective, what I can do. So I can read, write, execute from this level. Really, the only thing I can't do from a permissions perspective from a contributor role is reshare content, so I can't share it out. And I can't view the logs, so I can't perform audits on things that are happening within the environment. As a viewer, all I can do is read and view outputs. View outputs means just whenever I have a notebook open, there's an output that's displayed. I can read those outputs as well, or view those outputs, or read data from the files and tables. But I can't write back to it. I can't execute things. I can't do things like that. I can, however, if you notice, under the viewer role, there's going to be these three little more options, and I can add read all. They still won't be able to write, so that we're still at a read level with this. But this allows me a little bit more flexibility to say, if I want this individual to be able to read all the information that's associated with their certain file or table, I can add that permission in there. That gives me the flexibility to add permissions and override the built-in ones. So this is the Lakehouse itself. What about the analytics endpoint? Now, we kind of looked at those permissions in the content, right? The read data, read all, those. There's also other permissions that are located within this. But again, I can't really change the contributor one because they have the read all. But if I needed to add a read all to Gary's permissions, I can do that. So again, I got flexibility to override built-in permissions with this. And then finally, from our semantic model, remember, a default semantic model is always created whenever we create a Lakehouse, and then we can always create other ones. But let's look at the permissions in here. So just the workspace viewer, it goes by, because we're in a Power BI kind of context when we're talking about semantic models, it just goes by the workspace permissions, because that's initially what these were designed to handle, were Power BI permissions. So those are our permissions. Also, because we have contributor permissions, we can add additional access again to semantic models for this. So I guess bottom line is, since we have these granular permissions, always follow the least privilege rule, meaning you want to only give permissions to what this individual or group of individuals should be having access to. And then you can granularly add access, or you can change a built-in role permission. By the way, this doesn't just apply to users. If you have a group in your intra ID tenant, meaning that I may have a bunch of users that are associated with a group email, those groups can also be applied to certain workspace roles, ergo these other permissions as well. How does this apply to my SQL analytics? Well, let's go back in here, because you can also see that I have another layer of security that I can apply within the actual SQL endpoint, which is essentially a Lakehouse type warehouse. But there are security roles that I can apply to this. So there's some built-in roles here. So if I want to take this permission granularity to, if you've been in the SQL world and work with databases, this is how we apply roles into databases. So from a database perspective, I can apply certain granular roles to certain databases once I create them in this warehouse. So if I have dozens of databases that I've created within this warehouse, then I can apply certain permissions to certain databases. So that gives me that extra layer of granular protection that I can apply to the users based on their intra ID email accounts. So this is more flexibility and granularity within the permissions that I have. So that pretty much covers the permissions part. Now, shortcuts. So we'll load persisted data into our OneLake here at some point down the road. But for right now, I wanted to show you, since we're here and we talked about it in the content, to actually get some data in here externally or linked externally. So what I'm going to do is I'm going to go in the files. Why? Because I don't have any tables created necessarily in this storage account that I'm going to be referencing in this shortcut. So we're going to go under files here and we're going to create a new shortcut. So all I did was right click on this and we'll create new shortcuts. And you can see all the options here. So it's not just data lakes in Azure. I have S3 buckets or Google Cloud Storage, the Dataverse. So if we have Power Platform lists and objects within there, I can also reference those. And what I've noticed is that in the world of data, that cloud providers tend to play nice with each other when it comes to integrating with their services from a data perspective, because everybody kind of understands that a lot of large organizations are dealing with multiple clouds and they're going to need access to this. And I don't want to have to create some custom connector in order to access data in a object level storage solution. So I am going to connect to a data lake storage here. I have one that's already, I could create a new connection if I wanted to. In order to create a new connection, I could create a URL, and that's the endpoint into a certain data lake. So here, if I looked at this DDALDS data lake here, I have a data lake storage endpoint, and that's what it's really looking for, is that, right? And then we can create a new connection, give it a name, and then what kind of authentication I want to apply to it, whether that's a shared access signature. If it's already in my organization, I can use that. Let's say I have, if I'm working with clients and they have their own storage accounts, they can provide me temporary access through a shared access signature that allows me certain permissions into that storage account so I could read data in from there. And then if we could also apply service principals to cloud-based objects and get authentication in that way. But since I've already created this connection in here, I'm just going to use it. But it was that DDALDS, right? And you can see here that it found my data lake, and now I'm going to navigate through here. And what I'm going to do is I'm just going to, I'll navigate into the sales file and I'll just check mark this. Now this has CSV data in it, JSON data, and Parquet file information in here, but we'll go ahead and click next, and then we'll create this. And that's it. That's all it took for me to create the shortcut. Now when I go in here, you see that I have my CSV data, my JSON data, my Parquet data. So these were years of data. This is properties. I can go in here and I can explore this stuff now. So this is just an item in a JSON object. In my CSV, I can open up the CSV and look at that information as well. And I haven't loaded this into my OneLake. I'm literally accessing this from this external account. So it's connecting to this account and loading the data in. You can see that it can't preview Parquet data, but all this other information I can view and see. And then from here, I could create tables out of these, load them up into my tables, and then start creating my own semantic models or whatever. So we don't necessarily have to import a bunch of data into our OneLake. Yes, it's a great place for our central repository of data that we want everybody to work with, but I can create shortcuts into certain items like Lakehouses, and then be able to access external storage without me having to copy it and move it into my OneLake. So that does it for this exercise. Let's head back into the studio. Congratulations, detectives. You have successfully solved the mysteries of Fabric Lakehouses. You learned what they are, how to create and configure them, how to work with data and them using various tools and techniques, and how to secure them using different levels of permissions. By the way, if you happen to have a summer lake house without the cruel cousins, hit me up. Thanks for joining.